Hi guys, my name is Emma Doring and today I'm going to be presenting Physics 1 Lab 1, which is on constant velocity. So the general purpose behind this lab was just to verify Newton's second law by comparing the predicted updated positions of a metal rod moving at constant velocity to the observed updated positions of the metal rod. And the whole idea was that because this metal rod was moving at constant velocity, it should have a linear updated position throughout the entire time. Some background models and principles: the velocity update formula, the final velocity equals the initial velocity plus the net force divided by the mass times delta t, and then the position update formula, which just says that the final position equals the initial position plus the average velocity times delta t, and then Newton's second law, which I just mentioned, but it says that the net force is equal to the change in momentum over the change in time, and this can also be stated as it equals the mass times the change in velocity over the change in time. And then the general results, I found that the change in position of the metal rod was linear on both the observed graph and the predicted graph. And both of these graphs aligned pretty well, but they were not perfect because of possible errors that may have skewed the data. The experiment details: the system was the metal rod, the surroundings was everything else, the table, the air, etc. Initial conditions: the time step was 0.033 seconds, and this was just the time step between frames of the metal rod moving in tracker. The initial position, negative 0.212 meters in the x direction, initial velocity, 32.27 meters per second in the x direction, and that was constant the whole time. And then delta t, which was the total time of the video, was 0.467 seconds. The steps: my lab group and I placed the metal rod on the table with a meter stick next to it. We began a video with all three of these things in the frame. We rolled the rod so that it moved forward in a straight line along the meter stick. I downloaded the video into Tracker, tracked the positions of the rod at each time stamp after clipping the video to only include when the rod was moving at constant velocity, used the given starter code for GlowScript to edit it so that it outputted a 3D model of the rod moving and a updated position graph and an updated velocity graph. And then also I put the two position graphs, both the observed from Tracker and the predicted from GlowScript, into an Excel sheet to make one graph with both of them so that I could compare the two. And then there's my video from Tracker with each of the time steps. Coding details: so the code was begun with initializing the position graph, velocity graph, and 3D model. That was in the starter code, and then I had to initialize all the variables needed for the position update formula. The mass, initial position, velocity, and time, as well as delta t. The net force was not used because it was supposed to be 0. The mass also was not used because the net force and velocity were 0. And then I began the while loop to make sure the time was set to be less than 0.467 seconds, wrote the position update formula, updated each variable, plotted the velocity and position time graphs, and then printed the final position. So these are the modeled results. On the left is the graph from Excel with the observed positions and predicted positions of the metal rod over time. You can see that both of them are linear, but they're not perfectly aligned because of the possible errors like I mentioned earlier. And then also on the right is just the 3D model of the rod moving at constant velocity from GlowScript. So the possible sources of error: adjusting the video to the incorrect frames in Tracker. I may have adjusted it so that it wasn't the entire video of the rod moving at constant velocity. And then also I may have measured the diameter of the metal rod incorrectly. There could have been clicking errors in Tracker when I was tracking each time step, and then forces that were unaccounted for, as well as rounding errors. Additional questions: so if the positive x-axis and negative x-axis were interchanged, the position graph slope would just be flipped, so it would be negative instead of positive. And then is it possible to conclude how many pushes and pulls are being added together to give 0 net force in the experiment? It's not possible given the data we collected, but we can also conclude that the net force was not actually 0 in this experiment because the observed position graph and predicted position graph were not identical. That's all. Thank you for watching.